Welcome back. So now that we've assembled our cam and we've assembled our individual cams and we've created our individual Excel graphs, the next thing we're going to do is we're actually going to sketch our cam on this polar graph paper. And to do that, we got to take a couple steps. And the first thing we need to do is actually, well, we need to figure out a good angle for a measurement on this cam to start with. And it seems clear to me that 0 degrees would be a good place to start, but it might not be for you. It doesn't really matter. I'm going to start with 0 degrees. And I'm going to look, what is that distance from the center of my cam to my follower? And to figure that out, well, I can see that's clearly the bottom or the top of this cam, depending on how you look at it. But I need to figure out what that distance will be for 0 degrees, and then I'm going to go ahead and file open, and I'm going to take a look at that cam. So I'm going to open up that cam that I'm working with, and what I'm doing is I'm actually going to recreate this graph, but I'm going to translate it down to be the size of our cam. If you think about it, this was just the distance of the follower movement in relation to the guide. But as we've learned, this is a recreation of the actual distance of the center of our cam to the bottom of the follower itself, just translate it up. So I'm just going to recreate that graph. And so to do that, what I'm going to do is I'm going to open up the extrusion that made this and find the sketch. And I'm going to edit that sketch. And what I want is, well, these lines are already drawn. I'm going to go ahead and redraw them so we can see what we're doing. What I'm going to do is I'm going to sketch a construction line. So open up my line and my construction tool. And I'm going to go from the center of my circle down to the bottom of this shape, which would be the 0 degree mark. And where did I get that from? Well, again, I'm looking, where is the connection of the center to the follower at 0 degrees? And if I was working with a different angle, I would go a different direction on my graph, obviously. But what I'm going to do with this is I'm going to dimension the construction line that I just created. And it's going to ask you, you can't change it because this is a fully constrained sketch. That's okay, except I just want to see the number, which is ½ an inch, which is huge. That tells me that even though at 0 degrees the follower was 1.715 from the guide, I'm going to actually widen this a little bit, our camshaft size is, well, let's say camshaft size, well, let's say distance from center. Say center distance of our camshaft. So I click over center distance of our camshaft. And I'm going to open it up a little bit more and move this over maybe a little bit. But that tells me that this number down here, well, this is 0 degrees, that distance of the follower to the guide is 1.715. 0 degrees off the cam to the follower is 0.5. And why is that so big? Well, this tells me the difference between these two numbers. And I can actually get that consistent distance. So I'm going to go ahead and select a random cell that I'm not using. So I don't know, maybe F. I can even widen F a little bit so I can work with it. But we look in here, we click on it, we hit equals. And I'm just going to use this as a quick formula to figure out what the difference between these two numbers. And maybe you can do it in your head, but just to be clear, I'm going to say, well, the 0 degree distance for the follower is 1.715. And the 0 degree distance for our center cam is 0.5. So I'm going to subtract 0.5. And I'm going to hit enter. And you can see I can get that discrepancy right here. It's 1.215. So why is that so important? Well, as I change the angles in Autodesk, go back, let's finish the sketch. We go back into this assembly. As you change the angles, you can see what that distance is from the center mark by comparing those two numbers. So what I mean is, I can say at each point, so at C, well, I should say this distance at C3, I'll open it up, equals C3, and I'm going to subtract that from that number that we just created, which is 1.215. And I can actually do that for all of these. And so what I'm going to do is I'm actually going to copy this cell, this formula here that I just created, and I'm going to paste it in each individual one. Now I'm going to use Control V on my keyboard to paste. And I can actually do it all at once. You might say, well, you could have just said that was 0.5. And yes, but you can't figure that out so quickly with all of these random numbers. So I'm going to hit Control V on my keyboard now that I've selected them all. And it'll automatically plug in that formula for each one. So for example, this one, well, let's say 180 degrees, is whatever this number is minus 1.215, which gives me this different number. And this is huge. The reason why it's huge is because I can now edit this graph to include these numbers and actually get the size of the can itself. So what I mean, well, I'm going to open up this graph. You can see I've only got these two selected, but I'm actually going to right click on it and go to select data. And what I'm going to do is I'm going to select more than just this. I'm going to select this section as well. So it should have started with these two just selected. I'm just going to reselect and drag all the way down to select my D column as well as my B and C. And so you can see I've got two series in my X column. And what I'm going to do is I'm going to hit OK. And you might say, okay, that's great, Mr. Anderson, but nothing's changed on our graph. But if you think about it, it's because the biggest value on this is 1.215 in this column, and this only goes down to 1.4 in my case. So what I need to do is I actually need to edit my y-axis. So I'm going to double click on it. You need to make sure you have this bar selected underneath axis options and open up axis options. And I'm going to change the minimum of my y-axis. I'm going to change it to 0. And then I'm going to change this one to, I don't need it to go that high. I'm going to change this to 2.5 because it looks like 2.5 is enough to get both graphs. And then I don't like all these random lines. I want to make this a little bit more readable. I'm going to make this 0.2. We look, and that makes it a little bit more nice. But you can see we've recreated the same exact graph. We just translated it down to the size of the can, whereas this is the distance the follower moves in relations to the guide. But it's the same graph, and this is the one we're actually going to use to create our hair. And so let me give you an example, okay? So if you think about it, let's go ahead and change this to 180 degrees. So we change it to 180. And hold on, we're having some technical difficulties. Let's try changing it to 120 first and see what happens. 120, and that moves it. And then I change it to 180, just have a hard time spinning around all the way. But now it's at 180. This distance from the center of our cam to the bottom of the follower is going to be, well, what do we get? We got at 180 degrees, the distance from the center of the cam to the follower is 1.25. And if we look back, we open up this sketch again, and we get that distance, you will notice that this construction line right here, let me get the construction line open, is exactly 1.25. So we dimension it, and yes, we get 1.25 there, which is huge, because that means Excel did all the work for us. It calculated it all for us, and now we know all the values at 0 degrees, at 15 degrees, at 30. And so this is what we are actually going to use our polar graph paper for. We're going to open this up, or we're going to grab a piece of polar graph paper, and we are going to start sketching the various points at the various angles here. If you look onto this graph, so you notice at 0 degrees, we've got 0.5, for example. Okay, so what am I looking at here? Well, this is 1 inch, this is 2 inch, these big circles. Okay, so that means, how many we got? 1, 2, 3, 4, 5. So these are in fifths. So this is 0.2, this is 0.4, this is 0.6. But at 0 degrees, it says that it's at 0.5 inches. So we go, okay, 0.2, 0.4. So here would be 0.5. Okay, and at 15 degrees, it's the same. It's 0.5. And in fact, all of them are 0.5 all the way until what? Where does it stop? All the way to 120 degrees. So I'm just going to go ahead and say, okay, well, this would be 60 degrees. This is 75 degrees. It's still half an inch. And I'm just going to connect the dots, essentially. So now we're at 105, and I'm going to double check. 105 is still 0.5 inches, okay? But at 120, it's going to get a little bit bigger. And I can actually go back the other direction. We can say 360 degrees, which would, of course, be 0, is 0.5, okay? And then they're all 0.5 all the way up to 240 degrees. So I'm going to go ahead and go back this way because it's easier for me. It doesn't really matter because it's going in a circle. But essentially, we're going to sketch this hair cam. But once we get to, hold on, let me get rid of that dot there. Once we get to 240 degrees, or over here it was 120 degrees, so this is 270. That means this one would be, what? That would be 255. Okay, but then at 240, which is right here, which makes sense, it's across, it's symmetrical, right? It's going to get a little bit bigger here. We're just going to have to start guesstimating, which if you think about it, that's all those words. Well, you're just going to find it. So what is it? Just a little bit bigger, okay, and then we look at what's next. So I'm going to go back to 120. So 135 degrees is about 0.629. Okay, so this is 0.2, this is 0.4, this is 0.6, so it's just a little bit bigger than 0.629. That means maybe this one was a little bit higher over here, but just a little bit higher than 0.6. Okay, and so then what's next? Okay, we say at well, actually I should have drawn it over here, but yeah, this should be a little bit bigger than 0.6 as well. Okay, and then let's go to 135. Oh, we just did 150. Okay, 0.842. Oh, wow. Okay, so this is 0.8. This would be somewhere in the middle there. Got it. Okay, what's next? Then we say at 165 degrees, this is at 1.151. Okay, so this is 1, this is 1.2, and so that means 1.151 would be somewhere maybe, well, actually pretty close here. Okay, and I can actually mirror these, so this one would be about right here as well, and then this one would be about right here as well. And then all we got left is the 180 degrees, which would be 1.25. So this is 1.2, this is 1.4, so maybe about right there. And you can see we got the general outline, what kind of looks like. Hold on, let me get this back up here. It kind of looks like our pear. If you look at it from this view, it kind of looks, well, it's upside down, but you get the idea. And then what we can do is we can just kind of connect the dots. And so it's not going to be perfect. It's going to be pretty close to good, though. I mean, it's going to be the general shape of it. And depending on how good you are at finding those spots, it's going to depend on how well you draw your cam. But you get the idea. And that's what polar graph paper is for.